Do you know that there are an estimated 100 billion galaxies in the universe? And with the improved telescope technology in space, the number is likely to increase to about 200 billion. It is an inevitable fact that the deeper we look into the cosmos, the more galaxies we will discover. A study from 2016 estimates that the observable universe contains 2 trillion or 2 million galaxies. But the question is, what have we found so far and how our scientists are probing into them? Recently, a team of researchers from the Indian Institute of Astrophysics, Bengaluru, have discovered a faint but star-forming galaxy around 136 million light-years away. The discovery was not easy as this galaxy was hiding in front of a much brighter, bigger galaxy. The optical images indicate that the galaxy has a ghost-like appearance that shows hints of stars still forming within it. In this row, the PBNS team reached out to researchers from IIA including Jyoti Yadav, Mausami Das and Sudhanshu Barve to understand and unravel the mystery of the newly found galaxy.
We observed a sample of galaxies in the southern hemisphere with a South African telescope, and Sudhanshu at that time was in South Africa and he observed these galaxies. And this galaxy that we observed was one of those, and we thought it was an interacting galaxy. But when we looked at the UVIT data, UVIT is a AstroSat Indian telescope. It's India's first space telescope. So when we looked at our UV data from the UVIT telescope, we found that it was very abnormal. The look of the galaxy was very strange. And then we looked at more data. We looked at optical data. And that's when actually Jyoti discovered that actually it wasn't one galaxy, but it was 2 galaxies, and it was a superposition along our line of sight. That's why we thought it was one galaxy. So I think I'll now give it to Jyoti because she can now tell us about the next part.
Yeah, so as you mentioned that this is in the foreground of the galaxy and this is 6902A. So we were just studying the interacting galaxy, which is NGC 6902A, and interacting galaxies can affect the star formation activity in galaxies. So we were trying to understand how is the star formation activity in the interacting galaxy NGC 6902A. So for that, we were using FUV images, and FUV images were taken with the help of UVIT telescope on AstroSat. As ma'am mentioned, it is India's first space-based observatory. And FUV traces the recent star formation activity in galaxies. So using FUV data, we noticed that there are some star forming clumps which are present in the southern part of the galaxy, and this is 6902A. And these star forming complexes, which are very bright in the FUV map, they were very faint in the optical and near infrared map. So this prompted us to look into these features into more details, and that is why we estimated the distance of those star forming complexes, and we found out that these star forming complexes are at a distance of 136 million years. However, the galaxy that we were studying is at a distance of around 825 million light years, which is much farther than these star forming complexes. So this suggested us that these star forming complexes are part of a separate galaxy which is in the foreground of the galaxy, and this is 6902A. And due to their visual overlapping, they were mistakenly classified as an interacting system. And we named this foreground galaxy as UVIT J2020.
When we actually look at the sky, we look at the 2D projection of a 3D view actually. So like Maushmi and Jyoti mentioned that this galaxy was in the foreground of a big bright galaxy. So one thing apart from measuring the distances that Jyoti has done, we also wanted to basically show that or disentangle that these are 2 separate galaxies. So the near infrared data, the data that we observed from the South African telescope, that helped us actually in 2 ways. So one is basically the disentangling this galaxy visually, that images that we can basically show that the background galaxy is different than the foreground galaxy, and then measuring the mass of these 2 different galaxies. So how we do it? So we basically have the image in near infrared band, and then we basically simulate the galaxies with the various the mathematical function that represent the different parts of the galaxy. And then in this way, we basically modeled or simulated these two galaxies. And then using that simulation, we able to separate out these two galaxies. So this near infrared data helped us in doing that. And once we would able to separate out these two galaxies, we basically then using the another mathematical formulation, we able to calculate the stellar mass of both galaxies. And what we found was that obviously the galaxy that was in the background was much more massive than the foreground galaxy. And then that basically helped us to again investigate that this is a very different galaxy than what we see when these galaxies are sort of combined because of the projection effect.
The velocity and metallicity distribution maps and the star formation history indicate that UVIT J2022 has undergone 3 bursts of star formation, and the latest episode is ongoing. Hence, we asked the researchers about the new horizons that this galaxy will open for humankind.
The first importance of our discovery is that, of course, we discovered a new galaxy, which was not listed in the catalogs before. So that was great. And this research showed that the superposition of galaxies can lead to us missing galaxies. So that was one great point in the study. The second thing was that we found that it's a very diffuse galaxy. And diffuse galaxies are now quite an exciting topic in research, because now in our local universe, people are finding that there are more and more diffuse galaxies, faint galaxies. And that can be very important for estimating the matter in our universe, because previously we missed them. We did not detect them. So detecting a very diffuse, low surface density galaxy is very important for understanding the mass distribution in our universe. So that, I think, was the second point. The third point was that we could see that star formation had been triggered, as you said, in 3 bursts. So that means these diffuse galaxies, which previously people thought did not form stars, can be triggered into star formation, provided they have some trigger. Maybe another galaxy went past it, or maybe it had enough gas to suddenly, start forming stars. So I think these 3 are the basic points in our discovery. But let me also ask Jyoti to tell you something more, because I've just given it briefly.
Yeah, so I just wanted to mention that there could be similar galaxies which are star forming and very bright in FUV or H alpha, which are the tracers of recent star formation activity, but they go missing in the optical and near infrared surveys because they are very faint in those wavelengths. So using FUV and H alpha tracers for these galaxies will help us in detecting new galaxies, new star forming galaxies.
I would also like to add something here. As we know that this foreground galaxy is a very low surface brightness galaxy, or a faint galaxy which is forming stars. So this is what we are basically chasing now. Now the given that we have so much advances in technology, and we would like to build the instrument telescope such that we can basically chase these kind of a low surface brightness features, galaxies in the universe, that basically help us to understand how basically universe is basically built. So that's why we are looking after a bigger and bigger telescope. We want to detect fainter and fainter object to basically find out these missing low surface brightness objects, which otherwise from the small telescope we would not able to discover.
More than ever, communicating scientific researches to the public has become essential. It is a collective responsibility to understand and disseminate scientific information in a language that is easily understood by the common man. Let's hear what the researchers have to say on that.
One of the things is all the institutes that we have in our country now are having very active public outreach programs. So in the public outreach programs, we try to explain science, the science especially that we are doing, to the school students, to college graduates, but also to the general public, using certain sky watching days or lectures, public lectures. Then we have, of course, the Science Day every February. So using various events like this, but we have also started a lot more aggressive programs now where we will be trying to visit rural areas and to also explain our work and in general explain astronomy in the regional languages, so it is more understandable, because not everyone uses English. So we have started, at least in IIA, we have started these programs rather aggressively. This is one of the things, and maybe Jyoti and Sudhanshu can also contribute.
Yeah, I would like to add here is that what happens is that when we publish something, then also because it is written in a scientific language, so we need to actually translate it into a level where we can convey our science to our community. So it basically takes some time to do that. Hence, as you asked, that why it has taken some time to get it out in the public, because that is very important. The language that we should use should be understandable to most of the public, and we should be able to convey our work very efficiently. So that is one of the work that we are also started doing, and it is not only just in one language, but it is in a multiple language. And as Moshmi said, that these works that we do, we take it to various people, whether they are from the city or they are from the villages. So that is why some of these things takes some time to get into the public domain.
We asked the researchers about their future projects and interestingly got to know that from exploring supermassive black holes to finding new galaxies, our Indian researchers are probing into the universe with the intention to answer the unanswered question.
One of the things that we are exploring with telescopes all over the world is the clustering of supermassive black holes, basically. So we know that in the center of any galaxy, there is a massive black hole which accretes matter and gives out a lot of light. Now, what we are finding in our recent results is that you can have double or triple supermassive black holes coming together. And so there could be a clustering of these kind of massive black holes, say in galaxy groups, pairs. So this is something that we are exploring with multi-wavelength data. The second thing that we are looking at using UVIT is we are looking at star formation in these kind of diffuse galaxies or diffuse environments where you don't expect star formation. So there are many parts of galaxies, the outer parts, for example, which are ghost-like. You can't see them, you can barely see them, but you do see star formation in UV. So we are following this up with the UVIT telescope. And lastly, we are using the GMRT to map these galaxies in neutral hydrogen, because hydrogen is the fuel of star formation. Without hydrogen, you can't have star formation in the universe. So we are using the GMRT also to study the gas distribution in galaxies. So this is my perspective. Now maybe I'll hand it to Jyoti.
Yeah, so currently I am working on star formation and AGN activity in interacting galaxies. So when galaxy interacts, they can significantly affect the properties like their chemical composition, their morphology, and their gas content. And as ma'am has mentioned, that H1 is the fuel for star formation, so the star formation activity gets altered. So we try to understand how the interaction between the galaxies affect the star formation activity in the galaxies, and there is a supermassive black hole sitting at the center which can also start secreting gas if the galaxies have enough gas to fuel the supermassive black hole. So how that activity starts in the center of the galaxy. So we try to understand these using multi-wavelength data.
I would just like to add here is that since I'm collaborating with Moshmi, so some of these things we will do it together, hopefully, and then obviously we as a group we work in galaxies. So our idea is to understand various properties that Jyoti has mentioned about the galaxies, how in general they are evolving, but as an individual, I would say that my interest is also taking these aspect to a public. So I'm actually also like to work on data science actually. So idea is that there is so much data around. So I am actually working towards to take it to the public, building a citizen science project. So one such effort I have recently done with another institute, Astronomy Institute at Pune, IUCA. And then there we have actually developed a citizen science project called 1 billion galaxies actually. So idea here is that we actually provide public colorful images of the galaxies which have been taken from the one of the biggest telescopes on the earth, and then ask public to help us to classify various features in them. For example, if they are interacting, if they have any other features like ring around them, if they have any features like a dust lane, what we call a dark lanes around them. So the galaxies, if you look at, they comes with a variety of the features, and we basically ask public to develop or to help us to classify these features, which basically with these kind of billions of galaxies will ultimately help us to feed into the machine learning or artificial intelligence kind of programs, and help us to develop these kind of algorithms which in future we would like to use it when we have more data.
The universe is vast and certainly full of mysteries. Our science community is leaving no stone unturned to unravel the biggest mystery, our evolution. We will come back with more such interesting stories. Till then, thank you for watching.